And by the way, I want to thank Minqing for him to take up this job. And you can see that I have a logo, designed the logo, and also improve this DFTTK dramatically. Thanks, Minqing.
Thank you. Okay, hello everybody. And today I will give a short introduction of DFTTK. And as the name indicates, the DFTTK it means density functional theory toolkit. And first is the why DFTTK, because it has some fantastic features. And firstly, it is standard. The shoulder of a giant is based on the parameter that was or matter, and so on. And then it is a package to calculate the Gibbs energy of the finite temperature. And the third one is it has some expert settings, so you don't need to worry about your results. And of course, it is a high throughput DFT package, and it means you can submit a lot of structures, only one command line. And of course, it is robust because we have a relaxed skin to do the relax to make it robust. And the following is the details. First, it is standing on the shoulder of the giants. It is mainly depend on the parameter, custodian, and the firewalls, automate, and the MongoDB. And the parameter provides the analysis and the input and output of the DFTK, and the custodian it can handle some normal and common errors of the WASP, and it may recover your error settings. And the firewalls, it is a package to manage your drivers of the NetPy or the queue system, and Automator provides some automatically workflows to calculate different properties. And of course, we have the MongoDB to store the data, so make your to store your result and your input, make your result be reproducible. And then this is the main function of the DFTK is to calculate the Gibbs energy at finite temperature, and this is the main workflow of the Gibbs energy. And the only things you need to prepare is the required is the structure. You just need to prepare the real structure. Of course, you can adjust some other settings, and then you run these workflows, and then you get your results. In the workflow, this is the robust optimization firewalls. It makes the job robust, and after we run the robust optimization, we get the relaxed scheme, and then we can run the relaxed schemes for each deformations. And of course, for in this EV check firewalls, it is dynamic firewalls, so it means it can append some volumes if it is not enough. And after you finished your run, and then you can analyze the QHA properties. And of course, these figures, of course, illustrate the structures of the workflows. The workflows consist of some firewalls, and in each firewalls it consists of some file tasks. In each file task is handles some sample. It handles some simple questions such as copy the outputs, and then all of this consists of the workflows. And this is what DFTK is robust because we have a robust relaxed scheme, and this is the relaxed scheme for now. And firstly, we input in structure. Input a structure we want to relaxed scheme with the if equals to 7, it means the optimize the volume, and then we will run the 5, and if 5 passed, the pass it means the symmetry check passed, and then it will run the 4. The 4 is the arrow on the shape, burst of the arrow on the shape, and if 4 passed, we will get the relaxed scheme the 5 to 4. Of course, if 4 failed, and we will run the if equals to 2, And if 2 passed, we will compare the energy of the 5 and the 2. Which energy is low, we will use which one. Of course, we can have some other settings, such as if equals 4 equals to true. If this equals true, it will run 7 to 4, and this is the scheme for the previous DFTTK. After this, it is probably to get the lowest energy while keep the symmetry. And of course, DFTTK is it is still a high throughput DFTTK package. For this aspect, there are two aspects of this. Firstly, you can run lots of structure with one command, and the only thing you need is prepare the structures. And in the future, maybe you just need to prepare the structure template and then prepare your composition configurations. Of course, this is under development. And another aspect of this is it can automatically determine the funnel supercell matrix, because when you run lots of structures, different structures have different lattice and different orders. So the funnel supercell it is there to be different, and the DFTTK can automatically determine it. Of course, DFTTK is more than DFTTK. It is one of the ecosystem in our group. It can provide the data for the aspect, and the aspect will build and optimize the semi-dynamic database. And after you get the TDP file, and then you can use the package to exploring the semi-dynamic properties. And so in the following, I will give some results, well, some examples. From the installer to the ROM, and all of the necessary materials can be downloaded here. And I will just go through of the tutorials. Of course, firstly, the installer. For the installer, we recommend to using the virtual environment. Of course, you don't need to using the virtual environment. You can just go through here, but here I will show the using the virtual environment. For the virtual environment, here I provide several different methods. For example, you can use the Anaconda or Miniconda, or use the virtual environment. I will give the result to using this one. So using this one, you can need to just I will show all the examples in the ACI. So in the I'm sorry, I needed to relog in. I will show the install of the DFTTK from the beginning.
So this is in the ACI now, right?
Yeah, this is the ACI now.
Great.
So in the ACI, you just firstly you need to modularize, you need to load the Python, because in the system, if the Python it is too low. It is too low. It is 2.6.6, but for the DFTTK, you need to at least 3.6. So we needed to just load the Python. So here you will get the it is used Anaconda, and you will get the 3.6. And then after you load the Python, you can install the virtual environment package. Here I will use this as the example. Of course, you can use the Anaconda or the Miniconda. So here we just need to run this one to install the environment. Sorry. Okay. So in here, we just install the virtual environment package. After you finished this, you can create your virtual environment. Yeah, we use this command. And I'm sorry, because after you install this one, it will install in the local in these locations. You need we didn't add this pies to your pies environment, so we needed to use the absolutely pies, so we can then run this one. And later I will make some modification here. And then we created the environment. It is showed here. It is the land of the DFTTK. So we needed to active the environment. After you activate the environment, I will show the land of your environment, and then we need to say we need to we need to, because if you want to automatically load the environment settings, you can add this to your to here. You can add this one to here, and if you add this one, then each time you log in your system, it will automatically load your environment, your virtual environment.
Maybe I have one question here for Brandon. Brandon, do you think we should create a DFTTK.org?
I mean, you could. I don't think that there's enough documentation.
Not yet, right?
Yeah.
But if all this is going to be on the one with documentation along the way, maybe it's worthwhile to get the domain registered first. What do you think?
Sure.
Yeah, can you do that, please? Thank you. Because I can see documents are going to be coming more and more now.
Yeah, do you just want to have your person do that?
You want to just do that together? Now we have a SPA and PyCAFA, right?
Yeah, but I pay for the SPA one out of my pocket, but I don't really
No, we can pay. We can pay.
Okay.
Yeah. You get a receipt, we can reimburse it. Or we can directly use, yeah, maybe it's got a receipt, get all three together. Why do you get all three together in one account? Then we pay together.
Okay, I think Richard owns PyCalFed, so.
Or maybe do you want to put together or maybe we can discuss that one together. What do you register first? Then next time we serve us discuss together, so we'll see how to move forward.
Okay.
Okay, continue. Thank you.
Okay. So if you add that into your environment, each time you log in the ACI system, it will automatically note the environment settings. Just wait for a moment. You see here, it load it automatically.
Oh, that's nice.
So after you create the virtual environment, then we can install the DFTK. Of course, you can using the pipe to install the DFTK. It is, but currently it only supports the version no than the 0.2.1. And if you want to use the developer version, we need to run like this. But currently, the developer version is under tester. We did not to merge to our group's GitHub account. So here I will show to using my branch. And of course, in the future we will merge it. This is just for the then test. In the future, we will merge them to the our group's GitHub account. So here I just use the development version in my branch. After you clone it, you can install it. Install, you can use the pipe. You can use the pipe. Let me check. I'm sorry. And you install in the current folders. And this will install all of the dependents of the package. And of course, for these tutorials, we can just clone it in your local systems. This is just a clone the whole repository to your systems. Oh, sorry. So yeah, we just need to wait it finish the installer. So by here it is mainly using the operations above. You will install the DFTTK, and of course here I provide the method to install without the virtual environment. You can just follow these instructions. Then you don't need to install your virtual environment, but the virtual environment is recommended. And after we install the DFTTK, we need to configurations of the DFTTK. And here is the instruction of the configurations of DFTTK. And we will wait for the installers. And for the configurations, there are several things you need to prepare. And firstly is the DB file and the main launch pad field. It is the field to control the connection of the MongoDB. And if you want to use the DBK, you need to ask a brand for help to preparing these two fields. And of course, the other fields is not required. It's just optional. And for the supertension fields, there are some requirements for the names, and this is required by the manager. And this is, of course, we can use the supertension provided in the ACI. And so in the ACI, we just need to using the ACI the parameters. And let me see. Okay, it finished the run. If you finish the run, you can look if it is installed successfully. You can use the wish to detect the DFTTK. So here after we install the DFTTK, we will then make the configurations. Here I will use the examples, but this example is this is the test just for test. I will use the mine provided by Brandon. I will use mine. So you just need to prepare these two fields, and then you can use. You can look at the operations. Okay. Oh, sorry. Oh, so, oh. Oh, after you finish this one, you need set the you need sorry, let me
To
figure
give you some error message there.
yeah, it gives a message here.
Has not.
Oh, sorry. Oh, sorry, there is a little reverse. I will fix it later.
Does your my fireworker file
Yeah,
have
because
its DB file?
yeah, because here we still didn't install it, so we need to, so but here it required your settings there, and later I will fix that thing. Oh, it's slowly. Okay.
So that looks like something wrong in the script, right?
Oh, I'm sorry. Okay. For ACI, you just need to run the DFTTK configure, and for the all it means you will configure for the parameter and for the firewalls, and for ACI you just add the ACI. It will pass the certification provided by the ACI, and then run it. Yeah, this is the help of the configure, and it have other parameters, and for example, to specify the configure folders, to provide your Queen scripts, and this is to provide your API key, the keys of the material project, and now this is working. The warning is done. The warning just shows you didn't provide this option fields, and the time is worth spent on transfer the state potential from the ACI directions. After you run that command, then you will finish the configuration of the DFTK, and then you can to get started to run the DFTK. It is still not finished. Firstly, we let you know to run for the single structure or single folders. Here you will use the dash f, the parameters of dash f, and check it still didn't finish. And wait for a moment. Here I will cancel the comment, and then later I will fix these buggers. Sorry for that.
No problem. No problem. Thanks.
You see there will generate some folders by the configurations, and all fields is in the config fields. This is several fields we needed to configure for the firewalls, and this is the state potential of the WASP, and they of course, and in addition it will create it will add the environment to your PIs environment to your PIs, and then it will create the configurations for the parameter. Of course, here I didn't provide the API key, so it was just a none. So after your configuration, after you finish the configurations, and you can run the DFTK. Firstly, we can run the single structure. So for the single structure, we just need to use the dash f parameters, and we can run for example, we can run the single structure using here. Here we provide it here. I will use the all parameters to write out the workflows. And here I didn't submit it to the NumPy or the query system. Oh, sorry. After you finish your configurations, you needed to update your path environment. Oh, sorry. I forgot for that. Yeah, after you run this, it will create it will write out the workflow, and it will create metadata fields. It contains the metadata, and using the metadata, you can get after you finish the run, you can get all the data from the MongoDB using the metadata. Of course, we can run the structures in these folders. I will remove this. There are two postcards provided here. We just needed to, if we run the two fields here, we can just using this is the default. We can didn't provide it. We can just run here. It will run. It will run the two fields, the two structures. Yes, here it is run. It means it runs the two fields. After we finish the single structure, we can need to run for the multi-structures. For the multi-structures, we have two parameters. We have two parameters here using the MH or the R. For the MH, it means to make the it means the match of the match of it provides some expression to match the structures. For example, for here we can use for example we will run all of the structure start with the postcard, so we can use here. Here we just cut out the workflow. Yeah, here it will.
So you create all the files now for run run VASP, right?
Pardon?
So you create all the files to run the VASP here.
No, here I didn't to launch to submit it, to launch to the Launchpad and submit to the quiz. So it didn't generate the input field here.
Very good. That's very good. Okay.
I just should test it didn't launch because it will.
Yeah.
If you run actually, it will spend a lot of time.
Yeah, yeah. But you basically at this stage now you have everything set up just for run, right?
Yeah. I'm sorry. Here maybe there is some problems. Sorry, maybe here is some problems. It run all of the structures. Sorry, I will fix it later. Of course, we can use the dash R parameters. Sorry, here maybe there are some bugs. I will fix it later. Using the R, it means it will run all of the structures and including the structure in the subfolders. If there are some fields it is not supported, it will just skip it. Yeah, it means this is not a supported structure. It will skip it. So this is you see this create a lot of workflows, and for the subfolders, it will also create the workflows. For the structure supported by the DFTTK, it is listed here. It means the postcard or the concar or the charge card and the CIF and so on. And of course, sometimes we need to run with the specific settings. For example, we want to change the Inca or we want to change the Inca parameters or the podcast functions. We can just using the examples here. You can provide the settings field here. It was to let you change the Inca and the podcast function and the podcast settings. Example here. For example, we can do Yeah, here it right into the workflows. Your all of your settings here, it right in the workflows. So if we want to run the phone, of course, if we want to run, sometimes we need to run the funnel. So here is the settings for the run the funnel. It will set the funnel true and provide the matrix, and then we can. The settings. For settings, the default name is the settings, and of course you can change it by the -s parameters. Oh, sorry. So here it just set the funnel true and write the funnel matrix here. For the individual, if we have different structure, we can provide different settings. For example, we can use for this structure, we need to prepare the settings fields. Like here, it's using the settings dash and the field name of your structures, and of course, if there is no extra of the settings, it is a global settings of all of your structure. For example, for the silicon, we just run the funnel, so we can do the check. Oh. Yeah, here it is run the funnel, and then this is the matrix, and for the error, we just provide some extra settings of the in-car. Yeah, this is the parameters we write in the setting fields. For the global settings, they will just change the state of the temperature. So here it is changed to 10. By default, it is 5. And sometimes we don't want to using the settings using as the setting fields. We can using the -s parameters. Oh, I didn't write out the. Sorry, I didn't write out the workflows here. Here I didn't write out the workflow, so here they just created the metadata here. And this is for the run of the multi-structures. And of course, for the funnel, we have some extra parameters. It length pH parameters here. As shown before, it is if we needed to run the funnel for different structures, we needed to prepare different settings fields. If you just prepared one settings, it will using the settings for all of the structures. It is not a proper. It is not a suitable way to do that. So here we provide pH parameters. it will create, it will automatically determine the super cell, the funnel super cells. So here it will, for example, let me do a check. So here, for example, for the colon, it is just like this, and I. For this structure, it uses different different supercells. So this is the dash pH parameters, and of course sometimes we need to run different workflows. But for currently, it is only support the it only support for the gives energy, and for the Boeing charge, Boeing charge. So here you need to use the dash WF. It means workflows parameters. So here it is example of run the Boeing charge. You need to provide the metadata of your previous run. Then you can run the Boeing charge. Yeah, it is created the Boeing charge. It is a settings for the Boeing charge. This is shows the different workflows if we want to run, and the sixth is write out the workflow. Write out workflow just use the dash or parameters I have showed before. So here I didn't. I want to do it again. Finally, we need to submit our results to the NumPy or the Queen systems. We need to use the dash L on the dash M parameters. So for example, we wanted to run all of the structures. We just need to we just add to L and the M. When the M equals to 1, it means run. It means submit only one job to the quiz systems. If it is larger than 1, it will run multi jobs to the quiz systems. And this is the job submitted to the ACS system. And this is the basically usage of the DFTK run command, of course. And we can run the DFTK by the Python script. And here, this is this is an example of the run the browser gives energy from the Python script. You need to provide the settings. Of course, all of each of the settings expect the structure have the default settings, and then you need to then you just get the workflow and then determine if it to run to submit to the NumPy automatically or not. If you want to run other workflows from the by the Python script, you can reference this script. For example, here if here I didn't to submit to the multiplied, so I will change it to 2, and I will write out the overflow. I just do a test. Sorry. So here it just create the workflow here. It just create the workflow. It is the same with you run the DFTK. It is the same, but it just run from the Python script. And of course, using the some function provided by DFTK or the automator, you can to create your own workflows. For the create your own workflow, it is quite easy. And for example, here we just create a workflow to firstly you run the realize and then do the static. So here you just need to call the optimized firewalls from the DFTK firewalls, and then you can call the static firewalls from the DFTK static firewalls. And the thing is noting is you need the order and to set the parents. You need to set the parents and set the previous cache locations. And so here I will take example. It will create the first it will run the realize. First it will run the realize, and then it will run the static, and then it has the dependence. It means the static will run after the realize. So if you want to create your own workflows, you can refer these scripts. Of course, after you finish your ROM, you can get some data from the MongoDB. Here, I just provide scripts, and in the future, I will merge it into the DFTK. Here, you just need to provide the properties, and this provide the metadata, and then here I didn't to write out the. Here I didn't write out the figures because maybe there is no X11 authority. Then I just run. And the metadata is a result I run previously. This is for the phenotype, it is required the pass this package. Of course, if you wanted to handle it in the and you can of course you can handle the post processing from the Windows buffer window. Oh, sorry. Buffer Windows. I don't know how to get the DB fields from the systems. So, let me. I needed to copy another. Not here. I'm sorry.
So you're going to show more examples, or?
It's almost done.
Okay.
It's just this is just if you want to hand it run do the post processing by the script, you can get it from the if you want to do the post processing from the Windows, you need to provide the DB field. And this is an example. Of course, for more post processing, and that one developed a lot of contributions to the derivation. It will he will show the
Next week.
progress. Yeah, that's the Monday.
Yeah.
Okay, here it will just get the data you want. That's for example for the DAOs and for the band structure and the data. Okay, that's all.
Very good. Excellent.
Of course, this is the contributors and the testers and the readers, and this is some source links. And this is the homepage of the DFTTK, and this is the tutorials homepage, and this is some dependence. Thank you.
All right. That's excellent. I want to thank. I really want to thank Minqing for taking the leadership to make it in such a way. Now it really become a user tool now. That's great. That's great. So I'm going to, hey, John, maybe you want to stop the recording now?